Hey guys, welcome back. So now we are going to see about Monte Carlo control algorithm. Before we are getting into this, let's see where we can use this. What is the use of this Monte Carlo control algorithm? So the use of this algorithm is it will find the optimal policy in order to maximize the cumulative reward. So where we can use this algorithm? So let's say now a game is newly launched. So you're going to play that game. You might not know what are the moves you should take, which one you should give preference. So you might not know. By giving multiple tries and attempt, you come to a conclusion which should you give preference and how can you maximize the cumulative reward, what are the moves you should take at this particular time. So you might not know in the beginning what you should do. So later when you give multiple tries and attempt, you might come to a conclusion. So this is how you have to play in order to maximize the cumulative reward. In order to beat your high score, you have to use these kind of path. So you will find tricks and strategies by giving multiple tries and attempt. So likewise, it used to iterate the states and action value function in order to give you the optimal policy. So our motto is to maximize the cumulative reward. So this is why we are going for this Monte Carlo control algorithm. So let's see about the coding part. So at first we are importing TQDM. So basically it will track the progress. Then we are defining the function called MC underscore control and we are giving some several parameters. So env defines the environment in which agent is interacting with, and the gamma is the discount factor. Here we are giving a default value. Init alpha is nothing but it is the initial alpha. So alpha corresponds to the learning rate and alpha decay ratio is for learning rate scheduling, and init epsilon, min epsilon, epsilon decay ratio are the parameters for epsilon scheduling in the epsilon greedy policy, and n underscore episode or the number of episodes to run, max underscore steps or the maximum steps for per episode. So first visit here equal to true, so it will use the first visit, and we are here doing the initialization process. So these are the initialization process, and ns corresponds to the number of states, na corresponds to the number of actions, and discounts, so discount factors for each time step in an episode, and alpha corresponds to the learning rate, and epsilon so decay schedules for learning rate, and pi corresponds to the policy, q corresponds to the action value function. So here the pi track will track the policy over episodes, and q underscore track to keep track of q over episodes, and then we are going for action selection. So this select underscore action will select an action using the epsilon greedy policy. Then we are going for the main loop over episodes. So it will iterate over episodes, generates a trajectory. So trajectory is nothing but is a collection of states, actions as well as rewards. So multiple actions, states, rewards corresponds to experience. So these experience together is known as trajectory, and updates the action value function q using the first visit or every visit MC method. So MC method is corresponds to the Monte Carlo method, and then we are extracting the optimal policy and value function. So here v is the state value function derived from q, pi is the optimal policy derived from q, q corresponds to the action value function. Then we are running the function and printing the results. So runs the MC underscore function, prints the action value function, state value function, and the policy. So what are the missing function in this? So decay schedule. So this function should generate a schedule for decaying. So that is alpha and epsilon over episodes, and generate trajectory. So this function should generate a trajectory by interacting with the environment, and also the print state value function and print policy. So these functions should print the value function and policy in a readable format. So this is the output. So here we are getting the action value function, state value function, and the optimal policy.